Hello everyone, hope you guys are doing well. This is your Dilgam Israfilov, aka your savior, to help you out to ace the exam. So first of all, I'm gonna go through some of the PowerPoints, and I have put in here some questions. And once you have done these questions, and you like not just watch the video but actually do it, pause the video and write it, it's going to help you out massively to have a successful exam. Okay, so first of all, about measurement uncertainty. So we're going to talk about in this part about absolute and relative uncertainty. If you guys remember, we have done it in the lab. So we had a burette in the lab, and on the top part there was plus minus the measurement uncertainty written on it. So we have it in here too. This is our burette, and if you read the top part, it shows us the measurement uncertainty. Specifically in this example, it gives you that 0.02 plus minus is given as absolute uncertainty. Okay, so if they give you plus minus 0.02 centimeter cube with units like this, you know that you're talking about absolute uncertainty. That means that, for example, I'm going to continue reading. It says, during the titration, the volume of this much concentration solution of hydrochloric acid at the end point was recorded as this much, 12.25. So meaning that we run the experiment, and the reading we have left there is 12.25. And because our uncertainty is 0.02, that means that our actual value is in between here, which is going to be 12.23 and 12.27. Okay? So this is how you get your range. But what if I give you the range? Okay, what if I give you the range? Let's say I tell you that I have a range of 1220 and 1230 centimeter cube. This is my range, right? Okay, this is the range you have. How can we find the absolute uncertainty? So what you're going to do is that you need to deduct 1230 minus 1220 and divide it by 2, which will give you 0.1 centimeter cube. So this will be plus minus 0.1. In this case, we have 0.02. If you apply it over here, you could see that 12.27 minus 12.23 divided by 2 gives you 0.02, which is already given to us. Okay. Anyways, so once you know your absolute uncertainty, which is 0.02, and it's given to us, you may get asked to find the relative uncertainty. Okay, relative uncertainty. What you need to do is whatever your reading is, in this case, we're given that it is 12.25. 12.25. Okay, so the formula is divide the absolute uncertainty by the reading, which is 0.02 divided by 12.25. And that value is going to give you relative uncertainty. But you can also multiply this by 100% to give you percentage relative uncertainty. Okay. Okay, so if you do the calculation, you would see that this number is going to give you 0.2%. And that is that for this example. Let's do one more. I have in here, again, my absolute uncertainty given to me. I have the reading here on the burette. Now it's telling me calculate the percentage relative uncertainty. Let's do this again. 0.02 divided by 22.18 multiplied by 100. Okay. And let's say if it asks you to get the range, it's going to be 12.18 plus 0.02 and 12.2018 minus 0.02, which will give you the range of, from here you get the range of 22.16 up to 22.20. Okay, so this is your range. Okay, so now that we covered the measurement uncertainty, let's move into polymerization. We have already done this many times, but I just wanted to emphasize there are two ways to polymerize. Polymer is just a long chain of small monomers. So let's say I have one monomer, if I'll be able to write monomer here, monomer connects to another monomer and then connects to another monomer, and it gives us many of these monomers connected. The whole thing is called polymer. Okay, the plastics and everything. There are two ways to make polymers. One of them is addition polymerization. The other one is condensation polymerization. We have done this in biochemistry, and I'm going to remind you about this later on. Condensation polymerization. Okay, so addition polymerization, how it happens. Let's say I have one ethylene, which is other name is ethene. Okay, so I have ethene. We know that methane is 1, ethane is 2, propan is 3, butan is 4, pentan is 5, hexane is 6, heptane is 7, octane is 8, nonan is 9, decan is 10. October, November, December. Remember this because we have done it so many times, you need to know this already. Okay, ethane has 2 carbons, as you see. So ethene is alkene, so I have 2 carbons and 4 hydrogens. Formula of alkenes are like this. Okay, so alkene, CnH2n, right? So when I add them up, the thing I'm gonna do is that I'm gonna grab this one ethene. Actually, not one. I will grab many of them. So these are hydrogens. As you see, I have 4 bonds on carbon. 1, 2, 3, 4. 1, 2, 3, 4. So I grab n number of ethenes, and what I will do, I'm gonna break this bond, and once I break it, it looks like this. Okay, and then what happens, because I have many of these ethenes that have bonds like this, they're gonna make a bond with each other. So let's have another one here, and they will make a bond between themselves, and it will continue on and on and on like that. Anyways, I wanted to sing a sonnet, but it doesn't happen at this point. Let's finish the exam paper first. Okay, so this is our polymer, and we're gonna call this polyethylene. The only thing I did here is adding the word poly in the beginning. Okay, so this is addition polymerization, meaning that I just kept adding one after another. Okay, now you can do this with propene. As you know, propene is ending is in. We know that it is alkene, CnH2n. I know that prop is 3, so it's gonna be C3H6, like 2 times 3, right? So what you need to do is you put carbon, 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 and then you put your hydrogens. 6 hydrogens. Oops, I made a mistake. This is, now you delete this one, and now you have your propene. And the bonding happens here on these carbons that are holding the double bond. So we break this double bond, like we break one of them, and then we keep adding one after another. And this is the short version of it. You see the bracket showing that n amount of these connected, and we call this propylene. Okay. So the formula, problem solving with polymers. This is a super example. Many of you got it, but I'm just gonna review for the exam. So M in here stands for the mass of the polymer, okay, molecular mass of polymer. And then M is the molar mass of one monomer. And then N is the amount of these monomer, and this is called degree of polymerization. Okay, so now in here you have find the relative molecular mass of polymer which was formed from ethylene polymerization. So ethylene, again, the formula of ethylene is C2H4. The other name of ethylene is ethene. And because it is alkene, we know that the formula is CnH2n, and two carbons will make it CnH4. As you see, it is 2, right? So I put 2 in here, and then I multiply 2 by 2. Okay, and you're given that carbon mass is 12, hydrogen is 1. So what you need to do is that 2 times 12 plus 4 times 1, which is going to give you the small m, okay, the small m, which will be 24 plus 4, it'll be 28 grams. So one monomer is 28 grams. Now it's telling you that you have 3,000 of them, meaning degree of polymerization is 3,000. So you put the bigger formula times n, which means 28 gram multiplied by 3,000, which will give you 84,000 gram, which is 84 kilograms. Okay, so that is that. And then find the relative molecular mass of polymer which is formed from propene. Again, propene, you know that it is alkene, CnH2n. Normally polymers are formed from alkenes. Remember this. This is the formula of alkene. So propene, all you need to know that there are carbon number 3, which is why you need to memorize this table. So C3 and H gonna be 2 times 3, which will be 6. And you do your calculation again. M equals to, I got 3 carbons. I know that 1 carbon is 12 grams. So 3 times 12 plus 6 times 1. This will be 36 plus 6, which will be 42. And then you need to do, again, multiplication. M equals to small m multiplied by n. So 42, this is a gram, 42 grams multiplied by 5,000, which will be 210,000 grams, which is 210 kilograms, okay? That is that regarding the polymerization. Now, we're going to move on into alcohols, and we're going to talk about their oxidations. If you remember, we talked about alcohols, and we know the alcohols by their OH group, okay? When you see an OH group, you know that you're dealing with an alcohol. OH, just OH, okay? Just OH. Now, we need to find what kind of alcohol is it. Is it primary, secondary, or tertiary? Okay. In order to find this, you're going to look at the carbon that is holding the OH group, which is this carbon, right? Now, if this carbon has on him 2 or more hydrogens, this is a primary. So now, as you see, we got 2 carbons. So this is going to be a primary alcohol. Now let's look at this this alcohol. As you see, we'll look at this carbon, which is holding the OH. He has more than two hydrogens on him, directly attached to him, okay? Not the hydrogens in here or here, okay? We're talking about this guy's hydrogens, okay? Now, I've got two hydrogens, meaning that this is a primary alcohol as well. Now, when you look at this guy, which is holding one hydrogen will make you classified as secondary, okay? Secondary. This is primary. Now, when you have alcohol, you see this OH, right away I look at this carbon, the one that is holding the OH, and I don't see any hydrogen around him. And this is why we're gonna call this a tertiary alcohol, okay? Tertiary alcohol. Now, regarding the oxidation, I want to quickly tell you about this. Let's say I've got, so this R is just a variable. It can change, okay? Let's say I have OH like this, and I want to oxidize this. Oxidation. Oxidation means, one of the meaning is losing hydrogens, okay? Losing hydrogens, gaining oxygen, and then lose electron. Okay, in this case, we're gonna lose two hydrogens. Look at here. Because one of the hydrogens is gonna be lost from OH group, you see the hydrogen in here, we're gonna lose this hydrogen, and we're gonna lose the carbon. You see the carbon with the star that is holding the OH group is gonna lose another hydrogen. So we need to lose two hydrogens, okay? Now let's lose them. We're gonna lose them, and it's gonna look like this: R, C, O, and then H, right? In order to have, again, 4 bonds, you see I got 1, 2, and 3 bonds. I need to have 4 bonds on carbon, meaning valency of 4, right? That's why I will make 1 bond in here. And the other product is going to be formed, which is going to be H2O. The 2 hydrogens are coming from here. So 1 here and then 2 here. And then oxygen is this oxygen, okay? Now, when you have a group looking like this, RCOH, this is called, as you recognize, this is called aldehyde. Aldehyde. And you can see from here that because I have 2 hydrogens in here, I know that this is a primary alcohol, right? So primary alcohol. So we know that primary alcohol gives what? Through oxidation, aldehyde. Okay? While when you have alcohol which is not primary, so let's say I have another R1, this is R2, these are all variables, and then OH. As you see, the carbon that is holding the OH group has only 1 hydrogen. Means that this guy is secondary alcohol. Okay, secondary alcohol. Now let's lose both of the hydrogens. I'm going to lose both of them. So I will lose this one and this one. So 1 and 2. Now they're gone, right? So look at the product of the oxidation. This goes here. It's going to be looking like this. So oxygen. So let's write just the way it is. So oxygen here, and I got R2, R1. As you see, I have 3 bonds on carbon. This is not okay. I need to have 4 bonds. So this is how I compensate, and the product is water. Okay? And as you see, the way it looks, RCO, R1, R2. When you have a double bonded carbon with oxygen like this, and you don't have any hydrogen, this is called ketone. Okay. Now the tertiary alcohol R1, R2, and R3, and then I have OH. Tertiary alcohol, because he has only one hydrogen to lose and no hydrogen lose in here, he is not gonna go through oxidation, okay? So tertiary alcohol does not oxidize. Now let's see at these products. Let's write them. So as you see, I'm gonna lose this hydrogen and then one of these hydrogens. So the product is gonna be H3C. I'm just copying it down. So CH, CH2, CH3, and this is gonna be looking like this: CH double bond O. Because it was a primary alcohol, we got aldehyde. Okay. Now on this product, again, you will get an aldehyde. You will lose this hydrogen and this hydrogen, and then on this one you will lose this hydrogen and this hydrogen. You will get, I'm just going to write the product of this guy. So you have CH and then CH2, CH3. I've got here CH3 and then CH2, CH3. And then as you see, I lost the bond. I lost the two hydrogens, so this is the ketone. Now, because this is a tertiary alcohol, there is no product. Because this was a secondary alcohol, we got ketone in here. Okay, so this is your ketone. Now you can practice the other ones. Okay, so now we're still keep talking about alkenes. I just want to remind the alkene structure again. Alkenes, they have general formula CnH2n. So the simplest one is ethene. So I need to have a double bond and then I have hydrogens, okay? Because I have a double bond in here, you see the double bond in here, I can add stuff on it, okay? And this addition is gonna be done through bromination, meaning I will add bromine. Bromine comes in the atomic form, like two bromines come together, okay? Hydrogenation, two hydrogens, it's adding hydrogens. And then we have hydration, meaning adding water. Please do not confuse hydrogenation, addition of hydrogen, with hydration, meaning addition of water. We will also talk about Bayer test reaction. Bayer test reaction, okay? So now I'm gonna go through this again. Bromination, and I will have bromine added in here. So ethylene, as you see, I have a double bond, right? I'm gonna break this double bond, okay? Once I break it, I have carbon with, before I have it, I will have 3 bonds in here. 1, 2, 3, right? 3 bonds. And then what I will do, I'm gonna add the bromine underneath, as you see in here. So what I will do is that I bring bromine in here in the bottom, so they will have a bond too. This bond is breaking from here and this double bond is broken, and then they connect like this and bromine is added. As you see, bromine has a reddish brown color. We have done this in the lab. You see there is a tube, the glass tube in here. Through the glass tube, ethylene is a gas. Ethylene is pumped through. Ethylene is put through the glass tube inside here, while this test tube that holds bromine is a reddish brown. Because the bubbles are coming out from here and ethylene is coming out, it makes a new product, 1,2-dibromethane, which is colorless. That's why the color turned colorless. That means our bromine test turned out to be positive, okay? So when you have a change like this, you know that you have in here alkene. For now, we just talk about alkene. You can have alkynes in there too, but this is out of our curriculum. You need to know that we have alkene. Alkene means there is unsaturation. Okay, unsaturation. The reason we have the way to denote unsaturation is when you see a double bond in here, you know that it is unsaturated, and once you add the bromine to it, it will turn colorless. Okay, now we're going to talk about hydrogenation, addition of hydrogen. Hydrogenation. I emphasize this a lot. Okay, so when you have alkene and you add hydrogen to it, you will get an alkane. For example, the molecular formula of alkene is CnH2n. And when you add hydrogen to it, look at what happens. The formula of alkene, CnH2n plus 2. As you see, the two hydrogens came into the formula. Okay, so I had here a double bond. I broke the double bond, and two hydrogens in the bottom. The bond is broken in between them two, and then I make a bond, and this is the final product. From ethene, you see the ending ethene, I get ethane. So 2-butene gives me butane. Now, hydration reaction. Hydration is, hydration is like you drink water, right? Go hydrate yourself. You can remember it from here. So hydration is addition of water. So, but in hydration, there is one thing you need to remember. Markovnikov's rule means rich get richer. The truth of life, you need to remember this. Rich gets richer and poor stay poor. Nevertheless, let's go back to chemistry. I've got here water. So I've got two carbons in here, right? Holding the double bonds. So that double bond is going to be broken. But as you see, the carbon that is in red has less hydrogen, while the carbon with the blue has two hydrogens. Let's write this in an open form because you guys are confused. Okay, so I've got 3 carbons, right? I need to know that carbon always has 4 bonds. Remember this rule, okay? If you don't have a 4 bonds on carbon, you know that you're making a mistake. Anyways, as you see, I've got 3 hydrogens. I'm gonna put this in here. And then I've got this carbon. You see, I put 1 hydrogen here. And then I got another carbon with 2 hydrogens. And then I make a double bond. As you see, I have 4 bonds on carbons, on all of the carbons. Now, I'm gonna break this double bond, okay, when I do the hydration, meaning that I will add the water. The water has this shape, HOH, like this. Hydrogen always have 1 bond. Oxygen has 2 bonds, as you see, 1 and 2, right? 1 and 2. Hydrogen has only 1 bond, you see, attached to oxygen. Anyways, so rich gets richer. In here, richness is defined by having number of hydrogens. Whoever has more hydrogens, that one is richer. So as you see, the guy in the blue is the one who is rich, while this guy is the poor one, okay? So he's the one, the way the water breaks down, I have H in here, so this is broken from here. And then I'm gonna make a bond. I'm gonna make a bond like this. So this guy gets the OH while this guy gets the H. If you want to see the fragments, I'm gonna show you the fragments. So this, when I break the bond in here, the way it's gonna look like this. Okay, so I'm gonna delete this. So this is the way it happens. And then I will make, because this guy is a poor, he's gonna get the OH, while this guy is rich, he gets the hydrogen himself directly, okay? So that is the final product, and let's write it in the last form. So I can write this in a condensed form, CH3, and then this will be CHOH, and this will be CH3. And as you see in here, from this OH is held by this carbon, right? And I'm gonna check how many hydrogens he has directly attached to him, not this one, not this one. I'm talking about this hydrogen. I can see this is one hydrogen, so this is a secondary alcohol, okay? Secondary alcohol. Okay, so that is that. You need to also have acidic condition. Sulfuric acid is acidic condition. Now this is the line diagram. You can clearly see that this is carbon and he has one hydrogen while this carbon has no hydrogen. There's CH3, CH3, and CH3 here. So this guy is apparently rich. So when we do this reaction, the product will be like this. So OH is going to come out here. And this guy, because he gets the hydrogen, we don't write the hydrogen. So that is the final product. Okay. Now there is one more addition reaction, which is the Bayer test. Now the Bayer test, we did this in the lab. If you remember, dark purple mixture we had. And then what we did, we were changing, the color was changing and going towards colorless when we inserted the tube in here, when the alkene was going through the test tube. Okay, so it was pouring it out, like the bubbles were coming from here, like the gas is going in. And it started changing to the yellow, and further it goes into colorless. What is the product? What is the reaction that is happening? Again, we're gonna grab ethene. Okay, so I grab ethene and I have it in here. So the reaction KMNO4, what you need to write, it is Margansovka. And then you have the water solution. What do? We grab a little bit of powder, we throw it inside the water, and we brought it to your lab. Okay, and then what we did, we had ethene as a gas, and we inserted the tube inside KMNO4 solution, and the gas was going in. What happens in here is that this double bond is broken. And when it's broken, it looks like this. So I've got carbon, carbon. So you see, I broke the double bond. Now, the rest of the stuff is gonna be, I'm just gonna add OH here and OH here. We made an alcohol, but this alcohol, because it has two OHs, it's called diol. And this is actually an antifreeze. You put this in your car if you are, if you want to keep your car cool, which is actually you want to do it because engine overheats, so you want to cool it down, right? So this is the product. That's why you see the double bond in here. This is R. These are R's, meaning variables. We don't even care about them. We have carbon that is held by a double bond. I'm gonna break one of the bonds. Okay, so I broke the bond. And then I attached OH and OH, and this is the O. So let's make a calculation about this, okay? Let's make a calculation. What is the mass of ethene? Ethene is C2H4. As you see, I've got here 28 grams, okay? And the product is gonna be, this is called ethylene glycol, or you can just call it diol. We don't really care about the names. So you need to remember that on top of C2H4, you added two OHs, right? Oxygen is 16, and then hydrogen is 1, right? So you add two OHs, meaning 28 plus 16 plus 1 times 2, right? So this will be 28 plus 34, which will be 62 grams. Okay, so we got diol, or if you want to write the product molecular formula, it will be C2H4 H6O2, and the formula would be 62 grams. As you see, from 1 mole, I got another 1 mole, right? So 28 grams of this give me 62 grams of that. If I would, let's say, let's make a proportion. If I will tell you that I grab 56 grams of this, and how many grams of this is going to come out, you need to just do the proportion, meaning 56 is going to be X, 28 is going to be 62, and X would be 124 if you do the calculation. Okay, so that is the Bayer test. So Bayer test and bromine test are the tests that we perform on alkenes. We did this in the lab. You guys have done it. Apparently you did a good job. Hopefully you'll do a good job in the exam too. Now the same stoichiometric, like mathematical calculation, we can perform on hydration reaction as well. So I have here, for example, propene. We have already done it. We know that the formula is looking like this, but I want to show you the calculations. So we got here propene, 3 carbons, right? So 3 carbons, and I have 6 hydrogens. So C3H6 plus H2O under acidic condition, and you get, as a product, you would see 3 carbons, and then I've got 8 hydrogens, C3, H8, and O. Okay, so now you have this. Let's look at the calculation. I know that the carbon is 12, hydrogen is 1 gram, right? So 3 times 12 plus 6 times 1 gives you 36 plus 6, which is 42 grams. Okay, so 42 grams, and then oxygen is 16. So 16 plus 2 times 1, which is for hydrogen, and 18 grams. So 42 grams coupled with 18 grams. As you see, let's check out this guy itself. C3 times 3 times 12 plus 8 times 1, and then 1 oxygen, which is 16, which would be 36 plus 8 plus 16, and this would be 60 grams. And as you see, so 42 grams added 18 grams, and you got 60 grams. If you do the math, you would see that these guys are adding up. Okay, so this is a simple math. And if I tell you that I'm going to be using, for example, 36, or let me say 72 grams of water, and I ask you how many grams of alcohol is made, okay, and then you say, okay, now I see that for 18 grams I got 60 grams. How about for 72 grams? So you're going to construct your proportion and you will solve for the math, and this would be 18x would be 72 multiplied by 60. X would be 72 multiplied by 60 divided by 18, and this would be 240 grams. Okay, perfect. So now about biochemistry. Biochemistry, we talked about metabolism, and we said that metabolism divides into 2 types of reactions. One is anabolic, the other one is catabolic. Anabolic is basically meaning that you make bigger structures, okay? Bigger, making bigger or more complex structure. And for that, this requires energy to build something, right? That's why this process is called endothermic, meaning we gotta put energy inside. Now, catabolic reactions, on the other hand, is breaking down complex structures. And when you break down the structure, it actually releases energy. Okay, so the way to remember this is that anabolic is that you can remember anabolic steroids. Anabolic steroids helps athletes to build muscle, right? Build muscle. And building muscle requires energy. That's why it is endothermic. While catabolic means that you are losing muscles. When you don't eat enough protein and you exhaust yourself, you will be losing muscles, and which is breaking down your muscles. So when it breaks down, you release energy in terms of sweat and heat. So that's how it happens. Now, we talked about photosynthesis and respiration. Photosynthesis is, I'm just going to write you the reaction right away. So during photosynthesis, where plants, they grab CO2 and water, and they make glucose and oxygen. That's how I breathe. That's how we breathe in, right? Like breathe in the air. And then you're gonna balance this. This is gonna be 6 carbons here, 6 water, and then 6 oxygens. Okay, just remember this. This is the photosynthesis. You need to have this as a product. While photosynthesis, because you make the complex structure, this is photosynthesis is gonna be anabolic reaction. Okay, anabolic reaction. That's why, and when anabolic reaction happens, we need to get heat, and actually we use the heat from the sun. Okay, heat from the sun. The plants, not we, plants use heat from the sunlight, and then it's not the heat specifically, it's actually sunlight. Sorry, sunlight. It grabs the sunlight. It's written as HV, and then CO2 and a water, and it produces glucose, which is much more complex structure. That's why it is endothermic. While respiration, on the other hand, that's what we do. We break down glucose. So you see the reaction. This is exactly just this reaction backwards. C6H2 H12O6 with oxygen, and it breaks down into CO2 and a water, and you balance it 6 6 6 in here. This is balanced, and this is the respiration reaction. Because we broke down a complex structure such as glucose, this is catabolic reaction. Catabolic reaction. And catabolic reaction releases energy. That's why it is exothermic. So energy is released here. Okay, so let's write this example from our exam. Calculate the mole amount of carbon dioxide used from the air in photosynthesis reaction of unknown plant if 44.8 liters of oxygen was produced. By the way, 1 mole of any gas, we said at STP is 22.4 liters. You need to know this because in the exam you're not gonna be given that. So let's first of all write our photosynthesis reaction. So 6 CO2 plus 6 water, 6 moles of water produces glucose, H2O6, and 6 moles of O2. Unless you are gonna write this, you're not gonna get it. Okay, so pause the video and write it. Calculate the mole amount. You see it's asking mole amount of carbon dioxide. So it is asking how many moles of this. Okay, let's write this in here. If you know that 44.8 liters of oxygen is produced, so you know that 44.8 liters is produced. How many moles is that? Okay, we're asked about that. So first of all, let's find out how many moles is 44.8 liter. We know that 1 mole is 22.4 liters, and 44.8 liters is gonna be X mole. you can just do proportion, and this would be 22.4x equals to 44.8, x equals to 2 moles. So now we figured out that this is actually 2 mole, okay? So 2 moles of oxygen is produced. And how many moles of CO2 is actually required? You see, we need to have carbon dioxide to produce the oxygen. Now, these coefficients are here for a reason, okay? So if it doesn't have any, it means that there is 1, and this is 6 in here, right? So that means that 6 mole of CO2 with 6 moles of water produces 1 mole of glucose and 6 mole of oxygen. As you see, we're given in here the mole amount of CO2 and mole amount of O2 coming out. We are also given the mole amount of 2 mole coming out in this case. It's asking how many mole of CO2 you need, and this is why you construct your proportion. So 6 mole of CO2 gives 6 mole of O2, right? Sorry, I'm just gonna write it like this. So 6 mole of CO2 gives 6 mole of O2. And then X mole of CO2 gives 2 mole of O2. And then all you need to do is construct the proportion, and you can get the answer is that 6 gives 6, X gives 2, and 6x equals to 12, X equals to 2 mole. So you need to have 2 moles of CO2. That is that. And you can do the same reaction for respiration, okay? You need to know this, guys. For example, if I ask you how many grams of CO2 is produced, you need to find it from here. So we found that 2 moles of CO2 is produced. Let's find how many grams of CO2 is that. So the gram amount of CO2 is that 1 mole. Let's find the molar mass. We know that the carbon is 12, right? And we know that oxygen is 16. So 16 times 2 plus that gives you what? 44 gram. So 1 mole is 44 gram. And we know that 2 mole of CO2 were used, so it will be x gram, right? And then from here, you would find that x is 88 gram. So 88 gram of CO2, which is 2 moles, okay? And if I ask you, tell me how many liters produced. I mean, how many liters of CO2, carbon dioxide, is used, you will find it this way again. So you know that 1 mole is 22.4 liters. And if 2 mole were used, it would be x liters, and x would be 44.8 liters. Okay? So this is just a simple math. You need to do it on your own. Now, about amino acids. Now, amino acid, the reason we call them amino acid is because the structure of amino acid is like this. We got on this side NH, sorry, I'm gonna write NH2, and on this side I will have COOH. If you remember from our courses, this side I'm gonna write in an expanded form here too. So OH like this. And we have in here one H and then one R. So because this side is made carboxylic acid, and this side is made from amines, okay, we are gonna call them amino acid. Okay, what they did, they grabbed this amine side and then they made acid, amino acid. Now the carbon, you see the primary carbon in here is having 4 bonds. Okay, so 1, 2, 3, 4. One of them is taken by hydrogen, the other ones are taken by amine, carboxylic acid, and the R in here is actually a variable, so it can change. Okay, change. So now what happens with amino acids? So amino acids, as you see, one of the hydrogens can actually migrate into amine, and it's going to make the shape called zwitterion. The reason, because these acids are hydrogen donators, donates hydrogen, and amine is hydrogen acceptor. Okay, so one donates, the other one is accepting, right? So when this happens, I'm gonna write you the structure, so pause the video and write with me. So I've got here NH2, and then I've got CHR, and then COOH. So what happens, because this is acid, it donates this hydrogen leaves, right? So when this guy is leaving, the structure on this side is gonna be looking like this: COO, and then oxygen left without the hydrogen, right? It will carry the charge of negative. When oxygen has only one bond, it becomes negatively charged. And then we write the middle stuff as it is, R, and on this side we got the nitrogen with hydrogens, right? This nitrogen is taking that hydrogen to himself. So let's say it travels through here, he takes it, and now voila, we have one bond and hydrogen is in here. And when nitrogen has 4 bonds, it has the charge of plus. As you see, plus and negative cancel each other, we get net zero in the end, right? Which is the case in here. This one was a net zero in the beginning, so it migrated, nothing changed. But because we have both positive and negative together, this guy is called zwitterion. And Zwitter means hybrid in German, and ion means, you know, when the elements carry charges on them, oxygen -1, potassium +1, we call them ions from 10th grade. Because you have hybrid of plus and negative, it becomes zwitterion. Now, this is how it travels. So molecular form, so this is zwitterion. And zwitterion form exists at pH 7. pH 7 means neutral condition. If you remember the pH scale, when we had from 0 to 14, this side is acidic, and this side is basic or alkaline. And the 7 is right in the middle. It's nor acidic nor basic, so that means it is neutral. Okay, so acidic signs means lots of hydrogen plus, because acids we told about donates hydrogen, right? Because we have lots of acidic environment, we have lots of hydrogen pluses. And in alkaline environment, we have no free hydrogen plus. Only OHs, which are the actually taking all of the hydrogens, okay? So this OH grabs all of the hydrogens to himself and he makes the water. That's why we have no free hydrogen left, because we have lots of OH negative. So now, when we have pH 7, it is at zwitterion, right? But when we change the pH and we go to, let's say, pH 1 and pH 2, which is very acidic condition, in this case I have in here, so I'm just going to show you this example and then I'm going to clear it out. So let's say I add acid into this amino acid, and there are lots of hydrogens, right? Hydrogen pluses. Because this nitrogen is full, and then this guy is missing one of his hydrogen, he's going to take it right away to himself. while this guy is full, so he's gonna stay like that. That's why in acidic environment you see the NH3 is here, and then COOH, because the hydrogen is taken from the environment. Now this is how it's looking like, right? So this is why in acidic environment we will have cation. Cation means positively charged ion. Okay, positive ion. Because in here the negative is already gone. Before in zwitterion we had a negative. Now it is gone. In acidic environment we only have plus charge left. That's why it is cation. Now in alkaline environment, meaning if you increase the pH, going like somewhere here, 12, 13, 14, somewhere that, you have lots of OHs around, OH negative, okay? OH negative, and this OH negative wants to grab somebody's hydrogen. I told you that he's gonna grab it, right? So this OH, because this guy has the carboxylic side has no hydrogen left in him, while this NH3 has one extra, the way it looks like hydrogen here, and hydrogen here, he's gonna grab this hydrogen and take this with him. And the way it will look, you see, now we have NH2, two hydrogens, and this guy is gonna be left with the negative charge because he already lost this hydrogen. Now we have anion, and this anion, and this will happen when pH is 12, 13, 11, you know, like higher than 7. Higher than 7 is going to give you this anion. So amino acids, you need to remember this, gives cation, and you need to draw the shape if we ask you. And at acidic condition, and when we increase the pH, it needs to give an ion, and this is the shape, okay? So this are, for example, now let's do this one in the bottom. Alanine is a source of energy for muscle, central nervous system. It strengthens the immune system and helps the body use sugars. Okay, this is general information. Now it says identify formula of zwitterion for alanine in a strong acidic environment. Okay, so I know that this is going to be an acidic environment. First of all, I go to my table. We're going to have you give you a table. You need to find out how the alanine looks like. Now, you know that it is NH2, CH, COOH. All you need to find is this R part, right? And if you check it in the table, you will see that this R in alanine is CH3. Okay, so you have CH3 for alanine, and you know that in acidic environment, you will have lots of hydrogen pluses, right? So this hydrogen normally goes into here. So we lost this hydrogen. This is the zwitterion. And now you provide more hydrogen pluses in acidic environment. So you have as a product NH3, CH3, and COOH, like that. And this is your cation. That's what you needed to provide for your answer. Okay. Okay. Now we're gonna talk about the polymerization of amino acids. Now this type of polymerization is called condensation polymerization because we produce liquid water as a product. You know, if you go from gas to liquid state, this is called condensation. And because we produce liquid water, it is called condensation. So now, as you see, I have one amino acid and then another amino acid beside each other. So one amino acid A and then another A. As you see, the OH of one and then H of from amine side, one is carboxylic side. They combine together and I remove the water. What I will do, I'm just going to get rid of the water from here, and I will connect this carbon with this nitrogen and look at the product. Okay, this bond, you need to write this properly like this. Okay, very detailed when we ask you to write a dipeptide. And this bond is the peptide bond. Okay, peptide bond. And as you see, when I produced dipeptide, the reason is there are two amino acids. Two stands for D, three stands for 3, and tetra is 4. Okay, so when I make dipeptide, you see dipeptide meaning 2 amino acids, I produced 1 mole of water, right? So let's say I made 3 peptide, meaning I will combine A plus A plus A. This time I will make a 3 peptide will be A, and A. Because we combined 3 amino acids, we made 3 peptide. And 3 peptide will happen because I made 2 peptide bonds. Now in this case I will make 2 water. Now if I'll add 4 amino acids, this time I'm gonna make A dash A dash A dash A, and because as you see I have 3 peptide bonds, meaning I will have 3 waters. Okay, so it just goes accordingly. You have 1 less water. The generic formula looks like this: N amount of A gives you 1 mole of A dash N, and then this would be N minus 1 of water. Okay, so now let's do our question. It says we got cysteine. If you look up the cysteine, you would see it from the table. Says that calculate the mass of water in which was produced during the formation of 3 peptide from cysteine. Okay, so first of all, the way the cysteine looks. If they want me to write the open version of cysteine, this looks like this. So CH2 SH, if you would check out the table, you would see it. So this is cysteine. So I'm gonna write 3 of them together. Okay, so I wrote 3 of them together. So now let's look at here. As you see, I'm gonna remove the water from here, remove the water from here, and look at the final product. I'm just literally copy pasting whatever is left. You see this chunk? I'm gonna connect it with this chunk and with this chunk, because I no longer need to write this. Like I can write NH2 and then CH2 SH, and then I will write CO double bond, and this will be NH CH2 SH CO double bond, and then NH like that, and then CH2 SH, and then COOH. And as you see, because these are the peptide bonds, right? So because I made 3 peptide here, 3 peptide, and I produced 2 moles of water. Now I've been told that if I grab one cysteine, the molar mass of cysteine is 121 grams. So if we write like this, cysteine as 3 A's, so 3 cysteines, gives you A, and you get 2 moles of water, right? So this would be 3 times 121, which is 363, right? And you need to figure out what's the molar mass of water. If you check out, oxygen is 16, hydrogen is 1. So water would be 16 plus 2, which is 18 grams. So when you have 2 moles, this would be 36. So if you do the math, so we got 363 producing 36 grams of water. And if you deduct 363 from 36, you would get 327 grams. So this is the math, right? Now, you've been told that what if you produce 163.5 grams of tripeptide? Now, this is your general case. You produce from 363 grams of cysteine, you produce 327 of tripeptide, and 36 grams of water, right? What if you get 163.5 grams? How many grams of water you will produce here? All you need to do is construct a proportion, and you would get that 327x gives you 163.5 times 36, and x would be 163.5 times 36 divided by 327, and this would be 18 grams. It just dropped by 2 times. So that was the answer for your question in the exam. Now, again, we're gonna do a worksheet question. It says calculate the mass of water in condensation reaction if 3 of the same amino acid were used. It's known that the molar mass of amino acids is 89 grams, while the mass of the former tripeptide is 46.2 grams. Okay, so again, same amino acids, we use 3 of them, right? So 3 times A gives you A dash A dash A. And because you made tripeptide, you see we got 2 bonds, meaning that you will have 2 moles of water, right? So you've been told that this is 89 grams each. So 3 times 89 would be 267 grams, okay? And you know that you produced 2 moles of water. Again, the 1 mole of water is 18 grams because oxygen is 16 and hydrogen is 1. So 2 times 18 would be 36 grams, right? So you have from 267, you produced 36 grams. And how many you get in here, all you need to do is deduct that, and this would be 231 grams, right? So this is grams and grams. And it says to you that while the mass, if it's known that the molar mass of amino acid is 89, find the mass of water if 46.2 grams of tripeptide is formed. So now in this case, you've been told that what if 46.2 grams are produced? How many grams of water are going to be produced at the same time? So you need to construct your proportion, and this would be 46.2 gives you x, 231 gives you 36. And if you will do the math, this would be 46.2, 231, and this would be 7.2 grams. Okay, so that is that. And then we go into the structure of proteins. So I told you when the condensation polymerization happens, you see one amino acid connected to the other one. These are all different amino acids, and they are connected to each other. And this connection gives you the primary structure. So this is a primary structure. We call, when amino acids, they add up together, so the polymer of amino acid is gonna be protein. The ultimate product is protein. Okay? So primary structure of the protein is looking like this, right? Now, when they are interacting with each other due to hydrogen bonding, you see, like we have in here, so amino acids connected to each other. So hydrogen bond is happening between oxygen and hydrogen. You see in here, I've got carboxylic group with the amine group, right? So they are attracting each other, right? Like this. And then when they are attracting each other like that, they're gonna start making like close structures. This structure is called beta-pleated sheet, beta-pleated sheets. And this structure is called alpha helix sheet, alpha helix, sorry. So alpha helix goes like this. The structure of alpha helix goes like spiral. And they are all connected with each other with the hydrogen bonding, Beta-pleated sheets as well. And this structure is called secondary, okay, secondary structure of protein. While the tertiary structure, in this case we have this type of bonding. You need to know this. Hydrogen bonding is there too, but we also have ionic, disulfide, weak hydrophobic interaction as well. If you don't understand, you can check out my video on this. I go into more detail. So what happens, you see this one alpha helix and then another alpha helix. You see the blue ones are like beta-pleated sheets. They all come together and they make a tertiary structure. This is the tertiary structure as you see in here. Now, when the tertiary structures combine together, they make the quaternary structure, and this is how it looks like. This is one tertiary structure, this is one tertiary structure, and this is one. And this is actually the muscle tissue. This is how it looks. We have it in our body. Okay, so that is that about the proteins. Now, regarding the lipids, lipids are divided into 4 types: triglyceride, phospholipids, steroids, and waxes. They are largely nonpolar, mainly defined by properties. They're insoluble in water, meaning they are hydrophobic. They're good for storing energy and chemical messaging, cell messengers, transport, and thermal body insulation. Now, when you have saturated fats, they don't have any double bond in them, and that's why they are looking straight. But when you have unsaturation, meaning that you have a double bond, there is gonna be a bend in the structure. Okay, so as you see the bend structure, they are all unsaturated fats, while the saturated one is the one that is in here. Okay, so because the saturated fats, they can combine together very easily, you can stack them up like this, and they become highly dense. Their density is higher. Because they have a higher density, their melting point and boiling point will be higher. So they will be in solid state. For example, when you have more of saturated fatty acid, you will have a solid structure. Okay, so you need to understand this. When you have saturated fatty acid, you will have solid structure, higher melting point higher, boiling point higher. But when you have unsaturated fatty acids, you will have melting point lower, boiling point lower, and it's going to go into the liquidy form, because it's not necessarily 100% liquid, but it's going to be a lower density compared to the saturated fatty acid. Acids, I'm just going to quickly review. So they go in the structure like this. This is carboxylic acid. when you have the R variable, let's say I've got carbon, 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 it's COOH like this, and I got here 3 hydrogens, 2 hydrogens, 2 in here, 2 here. I've got here 1, 2, 3, 4, 5, 6 carbon, right? So this is hexanoic acid. And because I don't have any double bond in here, this is saturated fatty acid. Okay? So now essential fatty acids, as you see, we have double bonds in here, right? And we have COOH. In the end, we know that it is fatty acid. So this fatty acid, we always count from the left side to find the omega number. Omega number is going to be the number of the carbon which holds the double bond. So you see, this is the first carbon, this is the second, and the third carbon, we have a double bond. The first double bond, okay, first double bond, we always put the number, omega 3. Now let's look at here. I see COOH, so I start counting from this side. 1, 2, 3, 4, 5, 6 carbon. So that's why this is omega 6 fatty acid. And then we got omega 9 fatty acid. So we're gonna start from this side. It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So omega 9 fatty acids. Okay, so you need to know this stuff too. Plants, seeds, vegetables, oils, they are omega 3 fatty acids. Fish, shellfish, good sources of omega 6 fatty acids. Okay, so now that we know fatty acids, we're going to combine them with glycerol. Now guys, I have seen your exam paper. You need to write this reaction maybe 4 or 5 times in right now, like before you get it, because you guys are making a big mistake and you're not going to get any points if you don't get it right. Okay, so stop the video and write this reaction properly. So glycerol is alcohol with 3 OHs, you see. So 3 OHs and 3 carbons. If you want to write it from the scratch, all you need to do, write 3 carbons like this. Put OH here, OH, and fill the carbon with hydrogens. So you see this carbon has 2 hydrogens, this one has 1, and this one has 2. And the combined structure looks like this, right? So this is your glycerol. And then you grab your fatty acid. I told you fatty acids have this OH and CO, you see COOH. And this R part is variable. It could be 4 carbons, 5 carbons, depending on the acid, okay? So what happens is that this fatty acid and this glycerol, they go into condensation reaction, meaning that we're gonna produce water. So we will grab H from glycerol and OH from fatty acid. And then you see, and then one more, and then one more. So we produce 1, 2, 3 moles of water. You see, 3 moles of water is produced. And then what happened in here is that they grabbed this chunk, you see, and they attached this to the carbon in here. So this one is attached here, this one is attached here, this carbon is attached to oxygen. All they did is remove the water and attach the carbon to oxygen. And this is the ester bond, okay? You need to practice this a lot. Now this is the generic formula, okay? Generic formula. Now in here, in the bottom one, we have the R part is given to us. You see in here, we got R1, R2 are the same, but R3 is different, okay? So when you have R1 is the same with R2 and R3, you see the R1s in here, the variables. If are the same, this is called simple triglyceride. If you have different R's, this is gonna be a mixed triglyceride, okay? So you need to see this. As you see, we got R1, R2 like this, and then R3 in the bottom, or we can have this version, R1 here, R2 here, and R3 in the middle, like that. Okay, so now hydrolysis of triglyceride. Hydrolysis is the opposite of condensation. Opposite of condensation. Like, you remember the reaction we had above? We combined glycerol with fatty acid. So what you do in acidic condition, you add the water, you heat it up in acidic environment, and you break this bond again, and you remake the stuff that you had in the beginning. So we went back to the same thing, okay? So what they did, this is a acidic hydrolysis, okay? Now there is also an alkaline, a basic hydrolysis, alkaline or basic, which means that we're gonna provide a base, we're gonna heat it. And in this case, we're gonna get back our glycerol, and we're gonna get our salt, which is the soap, okay, soap. So this OH, I wrote you this reaction in my video. The only thing is this sodium hydroxide ionizes into sodium plus and OH negative, right? So OH negative makes a bond from here and from here, and this bond is broken, and oxygen carries negative charge, and that negative charge combines with the sodium plus. So this is why the formula, so you see, now we got the product back to us again. So this is the hydrolysis, we got the glycerol and the soap. This is the saponification reaction, okay, saponification reaction. Now we're gonna do a quick example that we did with you guys. It says, write the general formula for saponification reaction. Okay, just the general formula from us. But in the beginning it says, during the saponification reaction, a mixture of triglyceride X and sodium hydroxide undergoes chemical reaction. Okay, in this specific case, 60 grams of hydroxide is used to treat 404 grams of mixed triglyceride. So pay attention here, it says mixed triglyceride. We use sodium hydroxide. By the way, guys, you need to remember, sodium hydroxide is used to make solid soap, and then potassium hydroxide is used to make liquid soap, okay? So, write the general formula. I'm gonna write you the general formula of triglyceride. So I need to, for saponification, I know that I will make the glycerol back, okay? So this is what I normally do. I put the glycerol as a product, and I know that I'm gonna put heat in here, and I use 3 moles of sodium hydroxide. Triglyceride is just, I write the glycerol carbons in here, CH, CH2, and then I'm gonna put in here oxygen, CO double bond, and R1. You need to practice this a lot, guys. Pause the video and write this reaction. If you don't write it, unfortunately, you're not going to be able to write this in the exam. Without the practice, doesn't work. Okay, so sodium hydroxide. You get your glycerol back. Again, as you see that this bond is broken. Now I have OCR1 and then sodium in here, and sodium R1, R2, and sodium oxide COR3. Okay, so now we told you that this is the reaction, right? Sodium hydroxide. What is the molar mass of sodium hydroxide? We got sodium 23, oxygen 16. So 23 plus 16 plus, and hydrogen is 1, right? So 1, it's going to become 40 grams. And we used 3 moles of sodium hydroxide meaning 120 grams of sodium hydroxide is used, right? Now, we're telling you that for 60 grams, 404 grams are used. So this is the mixed triglyceride, right? Mixed triglyceride. We're asking you the molar mass, meaning for 1 mole, what is this molar mass? We know that for 1 mole of triglyceride, 3 moles of sodium hydroxide is used, right? And you can find the molar mass of this guy. The way you will do it, so look at here in the bottom. I don't know the molar mass because I don't know the R's, right? I can't figure out, just like I did for sodium hydroxide, I put the elements and I figured out what is the molar mass. But because I don't know the R's, I'm gonna do it like this. I know the proportion that 404 grams are getting into reaction with 60 grams of sodium hydroxide. But I know that 1 mole of triglyceride, which is X gram, this is the molar mass, is reacting with 120 grams of sodium hydroxide. So I can do my proportion and get my number that X equals to, so 60X equals to 404 multiplied by 120, and X equals to 808 grams of triglyceride. So this is the molar mass of triglyceride, because for 1 mole reacts with 3 moles of sodium hydroxide. Now that is that regarding the lipids. Okay, now we're gonna go into the carbohydrates. We haven't covered a lot, so I'm just gonna go into the facts that we have done with you. The simple carbohydrates, they are simple sugars, easily digested, and they're resource of quick energy. And the example we did with you is a glucose. Glucose is written with the formula C6H12O6, and it is actually a monomer. Again, monomer is glucose. We write glucose like this. So the first, we got 6 carbons, right? We're gonna write open chain form of glucose. Open chain, we got carbon 4, and then 5 and 6. So the first carbon, we're gonna have an aldehyde. The last carbon, we will have a primary alcohol. Okay? Now all the other carbons in between, it will have secondary alcohol. Just HOH, HOH. You need to know this by heart, meaning that you need to memorize this. Okay? Memorize. Now, we're gonna number this 1, 2, 3, 4, 5, and 6 carbon. Okay? So we'll write it here. So what happens is that when I close this chain, I'm gonna close this. So the 5th carbon, the oxygen in here, oxygen is gonna attach to this first carbon, and then hydrogen is gonna migrate to this oxygen. We have done this in the class with you. The way it will look is that I have carbon. We will have here 5 carbons and 1 oxygen in the cycle, because the first carbon, I've got first carbon, 2nd, 3rd, 4th, 5th, and then oxygen in here. Oxygen that makes the cycle. Now, the cycle looks like 1, 2, 3, 4, and 5, right? So now let's look at the shape. So the first carbon opens up, and now in the first carbon we will have OH, because hydrogen from here migrated to this oxygen, right? So that's why we have OH and we have H. On the second carbon, I have OH and H. Third carbon, I have OH and H. Fourth carbon, I have H and OH. Fifth carbon, I have CH2OH and H. Okay, so if you can't memorize, like if you don't know how to write the closed chain, I would recommend you to write the line diagram like this. And each one have here OH. Okay, OH. Only one of them will have CH2OH. This is the closed chain. If you can't memorize this, you can use this shape. Okay, that's how you go from open chain to closed chain. But the main thing is you need to know how to number it, because the first carbon is here, second, third, fourth, fifth, and sixth is here. Okay, so this is your glucose, and glucose is super easily digested, quick energy, and simple sugar. The reason we call it simple because it is made of one monomer. It's simple, right? But when you have lots of glucose connected to each other, so glucose and many glucose connected to each other, you make polymer, and now that polymer is complex carbohydrate. Now we call one glucose cycle like this monosaccharide, meaning there is only one, right? Only one glucose in here. What if I have two of them? You see, now this is disaccharide. And I'm gonna show you how we make the disaccharide. So let's say you know how to draw the shape of monosaccharide. So I got OH, CH2OH, right? So this is one of them. Okay, so this is one of them. I'm gonna put 1, 2, 3, 4, 5, and 6, right? Now I'm gonna draw you another one in here, in the bottom. Look the way I put it. It's kind of important, so it'll be easier for you to write your disaccharide. So the same thing, I put the number 1, 2, 3, 4, 5, and 6, right? I'm gonna combine these guys together with the carbon number 1. You see this carbon? I put a star in here. And the carbon number 4. The OHs of these guys are important. Okay, OH from here and OH from here. What will happen is that OH of one and H of another one will get removed, and we will have condensation. There's again condensation, polymerization going again. We remove the water, and then the other product, you need to write the full version, guys. You need to practice this, okay? So pause the video and write your own version. So I'm just gonna literally copy paste everything that I have in here. So CH2OH, OH, OH, OH. On this one, I'm just gonna, sorry. CH2OH, OH. So now look at this one. Okay, so this OH here, and I have here oxygen, and they are connected to each other. As you see, this is the bond that I made, and this is a disaccharide that is made from two monosaccharides made from glucose, and it is called maltose. And if you would do the calculation, you would see that. So I combine one glucose with another one, C6H12O6, O6, because I removed one water, right? I removed one water. If you add them up, 6 plus 6 gives you C12. And then you plus 12 minus 2 hydrogens for water gives you H22. And oxygen, look at here, I've got 6 oxygens plus 6 oxygens. And then I minus 1 for water, which is 1 from here will be 11. So that's why it'll be oxygen 11. Okay, and you can do all of your calculations. You can just like, for example, glucose, what is the molar mass? 6 times 12, because carbon is 12. 12 times 1, hydrogen is 1. And then 6 times 16, because oxygen is 16. If you would do 72, 12, and then this is 96, and this will give you 180 grams, okay? So 180 grams plus 180 minus 18 gram. So what is the molar mass of this guy? You can do it. It would be 360 minus 18. It would be 342, because this side will add up to this side, right? They will be the same. It's like a math equation. Now, we also did this silver mirror test in the lab, if you guys remember. So we grabbed the glucose and we went through silver mirror test. Now the reaction itself, so this is the same glucose, right? The main thing that you need to pay attention to is this side. You see the aldehyde in here? There is an oxidation. You see the oxygen, this oxygen got added in. Now the oxidation happened. Okay, oxidation happened. And the reaction looks like this. So you had glucose, right? Glucose plus silver 2 oxide. This is your reagent for silver mirror test. Now, as a product, we have gluconic acid. We call it gluconic acid. Also, we produced 2 of the silver in order to balance this, right? Because we have 2 silvers in here and we need to balance the equation, right? So oxygen in here went into glucose and it made gluconic acid. And then the rest 2 silvers are here, right? Now, let's say we want to do calculation. Let's say we want to do calculation. I have glucose, which is 180 grams. And silver, if you look up in the periodic table, is 188 grams. So I have 2 silvers, meaning that 2 times 108 plus oxygen is 1 is going to be 16. So this is going to be 232 grams, right? So 180 plus 232 grams. Now, as a product, you will get, because glucose gets the oxygen, and we have 2 silvers in here. 2 silvers is going to be 2 times 108, which is 216. And then gluconic acid, molar mass, you can just do the calculation. This would be 412. And then it would be 196. So gluconic acid molar mass is 196 and 2 silvers are 216. Okay, so I'm just gonna write it nicely here. So let's say if I tell you that what if I used 360 grams of glucose, how many grams of silver I would make? Okay, so you would do just proportion. You see that? So you're gonna do 360 gives you X, 180 gives you 216 grams of silver, and you do your cross multiplication, and you would get that your X would be 432 grams of silver. And that is that. Okay, so now about this complex carbohydrates, you see like we have lots of them added up together. The reason complex carbohydrates are complex because they have lots of monomers. For example, they are longer to and which is why it's harder for us to digest them. For example, when you eat glucose, like something sugary, let's say a chocolate, right away you feel energized, right? Or maybe ice cream. But when you eat carrots, even though carrots inside them have sugar, it will take a lot of time for your body to digest, a lot more compared to other source of sugar such as ice cream. And which is why the more complex they get, the harder it's for us to digest. For example, the starch is even more complex. So you need to guys kind of go through this short chain of monosaccharides, meaning if you have less than 20 monomers, it's called oligosaccharides, okay? You need to know this stuff. Carrots are source of oligosaccharides. You cannot get sugar molecules out of it until you cook it for an hour. So that's why, like, you cook it, and that's when the sugar is coming out. Like, it breaks down into glucose. Now, polysaccharides, such as starch, they have inside them like many glucose molecules. And when you eat lots of starchy stuff, the reason we feel sleepy is because our body needs time and energy to digest, and all of the blood is flowing through to break down this starchy food, right, to small glucoses. That's why we feel sleepy after eating starchy food, such as rice and bread or fries and stuff like that. Now, glycogen, in this slide, you guys actually need to go through this. What is the glycogen? You need to learn what is glycan. Like, please go through this yourself, because you might get asked questions from here, such as polysaccharides are more than 20 monosaccharides together. Most carbohydrates in nature occur as polysaccharides. They are known as glycans, homopolysaccharides or heteropolysaccharides. Homo ones meaning that they are made from the same monosaccharide, such as just the glucose. But if they have glucose, fructose, and all that, it's going to be called heteropolysaccharide. Okay? Starch is only made of glucose. Storage form in plants, main carbohydrate in human diet, bread, pasta, cereals, potato, and rice. These are the basic stuff. You need to know this for just general knowledge in the world. And structure of glycogen, could you please go through this yourself, and you might get asked questions from here. And I wish you good luck. It was the best experience to go through this with you guys. I wish you best of the luck. I hope you all guys a success in the future. In this is just a final exam. Just get it done, finish strong. But there's gonna be much more, difficult exams in your life. I hope you best. I know that you guys got it. Take care.